Hi class, welcome back. So today's lesson will be about decorators. In this lesson, the goal will be to understand what a decorator does, how we can actually use it, what is the benefits of using it. So we're going to go over some of the basic syntax, understanding the decorators functions, applying multiple decorators, decorators with arguments, and building our own decorators. So what is a decorator? Decorating in Python is this concept where you enhance or modify the behavior of function or methods without actually changing their actual implementation. So what does that mean? It means that imagine that you have a function that you were given this function is something that you can't modify, like you can't literally go and change that function yourself, right? So it was probably maybe inherit, right? Or it's coming from a library or a some modules. And so you can literally change it. But what you can do is you can modify that function. Like you can make changes to it so it can act differently. So you can make some decorations to it. And so that's practically what you do is can we modify these functions that were given? And that's practically what decorating is. It's like imagine that you have a room and you wanna even though you still have the room, you can't change the structure of the room, right? You cannot go and maybe if you're a construction worker, right? But let's say that you can't change that room, right? You're living in an apartment, you can't change it. But what you can do is you can decorate it. You can maybe paint the walls, right? That doesn't change the structure of the function. You can paint the room. You can actually add some furniture, right? Some carpets, some sofas, things that make it look a little bit different or seem to be a little bit different. So that's practically what decorate will be. It's like decorating a room, a function that will be like your function or method with different styles and elements where each decorator represents a specific enhancement or modification to the actual room. That will be a enhancement or modification to the actual function. So that's practically what a decorator does. You're gonna see that it has a lot of power to it. So some of the basic syntax for a decorator, in order for us to be able to use a decorator, we first have to define our decorator function. So you can see here that we are defining, let me use a different color. So here we're defining our decorator function. And then within our decorator function, we're gonna define our wrapper. So here in our wrapper is where we're gonna be able to make any changes. We're gonna add some decoration, some modification to the actual function. So what we're doing here with this, and you don't have to call it the wrapper classes, the wrapper function, but it makes it easier for us that to think that this is where you're gonna make the modification. You can call it whatever you want, as long as you return the same name of the method. So let's go over this part, right? So let's say that I have a function, right? I want to modify. So what I can do is I can make it so that I can have some information or some computation being done before I call this function. I could actually make computations that I can pass into my function if I need to. And and so that way you can automatically every time you call it, it's gonna take those values from that modification. And then you can actually also add some aftermath modifications to your function. Now you have to return the name of the function that is going to involve that function that you're going to inherit. So this in here, we're passing the function as an argument to our decorator. So here we're passing this function that we want to be able to modify. And so we're going to pass this argument. And so as you can see here, it is going to be calculating some result value that we're going to be able to return as our wrapper. So now in order for us to be able to decorate a function, let's say that we want to decorate it. We want to decorate this function right here, the different function. This is not the same function as this one. This is called the decorator function, and this is going to be the decorated function. And so let's say that our decorator function it just says hello world. In order for us to be able to decorate this function, all we have to do is use the syntax at followed by the name of the function that is going to serve as our decorator. And so let's see this into action. So now what I want you guys to do is I want you guys to write this code right here, just for you guys to practice. I want you guys to write this code on Replit. So follow along with this part so you guys can try it out. So it's always good to when you're learning something is to follow along, try things out, just so it makes it a little more familiar. So I want you guys to write that out on your Replit. It's going to say decorators lesson video. So make sure that you guys open it up and use that part for you to follow along. And you're gonna be submitting that as your class lecture notes. Okay. So let me show you guys. Let me clear this up. And let's go into the Replit, right? So it should say decorator lesson. And so what you're gonna do, as you can see here, this is the same code. You can see here the decorator function. We need to pass in. You can call it whatever you want, but we're gonna call it funct because it's the function that we want to be able to decorate. But I can call it function, whatever you want to call it. But whatever that is going to be the function. It's going to act like a function. It's going to be the name of the function. So you need to follow by parentheses if you do that. So here, what we're doing is we're passing a function as an argument for our decorator function, which is going to be the function that we're decorating. So you can see here, we're going to print before the function. We're going to calculate some result. We're going to call this function we're going to call the function to return the result value, and then we're going to print the after the function, right? After it does some calculation. And then we're going to return the result, and then it's going to, what we're doing is returning this wrapper class to our decorator function. So this decorator function has a return value, which is the wrapper. This wrapper has a return value, which is the result. So in order for us to decorate our function, which is this one, this is our decorator function right there. In order for us to decorate that function, I need to call add decorator. So I have to say add decorator function, and it's going to automatically call this method right here. So what it's going to do is going to replace this decorator function with this wrapper function. Let me say that again. When you call this decorator, right, when you write add decorator function, what's going to happen is that you're going to replace this function with the wrapper function. So now instead of having the decorator function, you're going to have this wrapper class being called. And you can see here, right? So here's where we call in the function and we want to print the result. If I run this, you're going to see that it says before the function, after the function, and then it says the hello world. Now there's something interesting here that I want you guys to pay attention. Notice that even though I have the print before the function, I have the print before the function and then follow by the calling the function, and then I have the print after the function, the order in which we actually have this is different. And the reason is because remember, when we use this add decorator function, what we're doing is we're saying instead of using this decorator function, what we're doing is we're using the wrapper function. So now this is going to be executed first. Now this is going to process second, but we're not what's happening here is that we're not technically returning this value result until after we actually print the after function. So in order for us to be able to print the result, right? So remember, this decorator is being replaced by the wrapper function. So the wrapper function is going to print before action, is going to calculate that, It's going to print that, but then it's going to return it. It's going to return the value. So this is going to, at last, is going to return the value, which is going to be the hello world. So here is going to print the hello world after it actually call the after the function. So it's a very tricky thing, right? And I will show you guys how can it be modified a little bit to change that. But let me say that again. So remember, when you call the print decorator function, what you're doing is, because this decorated function it has a decorator at the top, what it's going to do is going to replace that function with the wrapper function. So it's going to print this first, calculate that second, but it's not gonna return it yet. Even though it's calling the function, it's not gonna return it yet because it hasn't finished. So it needs to first finish to be able to return the result. So before we return the result, it's going to print the after the function. So now it returns the result of hello world because that's what we're passing in. So when you call this decorator function, what you're saying is we're gonna pass this function as the funct here. And so now, sorry, trying to make it right. I'm highlighting this. Hopefully you can see it. I think you can see it there, right? So so now what this is going to do, this is going to return the value at last. And so that's what we're going to be printing. So that's why the order looks different. All right. All right, so understanding decorator functions. The decorators in Python are essential higher order functions that take another functions as arguments and returns a new function. So that's practically what we're gonna go a little more in detail, right? So in Python, a function are like first-class citizens, meaning they can be passed as arguments to other functions, as we're gonna be able to see right now, and we can use those functions within the function. So we can pass a function as an argument to another function. And we can pass as many functions as we want to. So that's not a restriction. And we can also return functions if we want to, or both. Accepting another function, the decorator function accepts another function, usually referred to as the funct in most examples as their arguments. Functions that represent the original function are being decorated. So that's what we were explaining here, right? So here I'm giving you guys an example where we take a function as an argument. So we're passing that to our decorator. So this is going to be our decorator. Well, yeah. So this is gonna be so this is more like not necessarily like a decorator, but it's a function that takes another function. So I just wanted to show you guys an example here where a function takes another function. So here's so we're saying this is going to be a function. As you can see, when we pass it in, it takes the form of a function, right? It's going to be the name of the function. Now we're gonna also pass a list. And what we're gonna say is that we're gonna add all the elements to this result list one by one. And so what we're doing is whatever function we're passing in, that's how we're gonna calculate the values that we're gonna add to a result. So if I pass in the square function, then it's going to square the number in the list. If we pass the q function, then it's going to q the functions in the list. As you can see, let's do the example, right? Here we have a list of 1, 2, 3, 4, 5. We're gonna call the function apply function to the list. We're gonna pass in the function square. So we're passing the name of the function. We pass in the list. And then we calculate, it's going to process, it's going to return the result, which is the list. So you can see it returns the result. We can do the same thing with the Q. And then we can pass in the list and we return the list. Right. So let's see this in example. So make sure that you guys code this part as well. I already coded, so I wanna save some time. And so let me uncode this part right here. So again, let me just close this so it makes it a little bigger. So we're gonna call this the higher order function where we pass in multiple functions. So this is the same code that we had there. And what we're doing is we're passing whatever function we pass in is going to represent this function that we have in the definition of this function, in the implementation of the function. So that's going to be passed over. The number list is just the array, and so on and so on, right? So as you can see, we're passing the values, and we can see that we get the list of numbers. So you can see here that we now return a list of squares and then a list of cubes. So we have passed in a function as the argument in our function. All right, so let's go to the next part. So make sure you guys code that. If you need to put pause. Understand decorator functions. So we define the wrapper function inside the decorator. So that's usually, we can call it wrapper, you can call it whatever you want as long as you return that function. The new function called the wrapper function is defined. This wrapper function typically contains the code that needs to be executed before and after the original function. We can also actually pass a more arguments if we need to into our wrapper function. And so that gives us the flexibility. Now we're gonna have this. I'm not sure if you have seen this before. This star allows us to be able to pass in multiple arguments without having to define how many they are. So this gives us a lot of flexibility. So it adjusts depending on however many we actually pass in the end. It allows decorator to set any number of positional and keyword arguments that original function might have. Also enables the decorator to pass these arguments to the original function when it's called. Additionally, the wrapper function can capture and return the values original, okay? And so again, returning the wrapper function, we can call it the decorator, and it automatically passes the decorator function and return the return wrapper. So I already explained that part, but let's see an example here. So here we have my decorator. And then here again, like we were saying before, we're gonna define this wrapper class. Again, you can call it whatever you want as long as your decorator returns that function, right? That name has to be the matching the return of your decorator. Okay, you can call it whatever you want. Now here, right, in our decorator, again, we're passing in a function name, and then our wrapper has this special notation, right? It's called the star args and the star keyword args arguments. So what it does is, again, this allows you to pass in as many arguments as you want to your function. So you can see here, it's going to be passed over to the function that we got from the argument of the original decorator. Again, this is because we have a star in front of it, is going to give us the flexibility to add as many arguments as you want without having to define it. So we can use a function that has 3 arguments or 1,000 arguments, and it still would work. And so you can see here, again, it's practically the same thing as before. We're going to do, before calling the function, we're going to do the result, and then we're going to print the after calling the function, and then we're going to result. So I just want to say, you can see how this is going to be able to return the value of Alex, right? So it's going to first print this, is going to calculate this part, but again, because you're returning the result and you're not return the result until you print after calling the function, that's why the order will be a little bit different. It will be before, after, and then the hello name. So let me show you guys that. And I'll show you guys how to fix that in a way. So let's comment this font, this part right here. And oh yes, I changed it here. I probably should change it there too. I end up changing it here. So let me put pause. Put pause. All right, so I changed it here. I put to the correct one. So I wanted to show you guys how we can actually have this proper order before get the the Greek name in the middle, right? And then the after calling the function. So if we ever want to do that, so let me just go back here. And before what we had was the result, right? We're taking the function's result. So this is your decorated function result, right? And we wanted to print hello world. But if we return the value in the function and we wanna return that as part of the wrapper, the order will be different. The order will be before, after, and hello world. But let's say that we want to have the hello world in the middle, right? Or in this case, the Alice. So what we need to do is instead of returning something, we just call the function, and the function does not, the greet function does not have a return value. This way, anything that is in the greet function will be executed in the middle, and then before before we can have the after calling function. So we run this, you can see that the that Alice, hello Alice, is now in the middle between the before calling and the after calling the function. So you can visually see that part. So that's one way if you have access to be able to change that greet one so it doesn't return something. So then you can see that that will be implemented in the middle, right? So make sure you guys code that part as well. Again, you can put pause and copy that. Applying multiple decorators, we can actually have multiple decorators for a function, and it will be exactly the same thing. Now, the order of execution would be if you have multiple decorators are applied to a function, the function is passed through each decorator in reverse order. This means that the decorator listed at the top is the first one to modify the function, followed by the decorator listed below, and so on until the original function is reached. Nested decorators is also possible to have decorators that are themselves decorated by other decorators. In such cases, the innermost decorator is applied first, allowed by the decorator that wraps it, and so on until the outermost decorator is applied. Chaining decorators, by chaining decorators, you can add different layers of functionality to a function. Each decorator can add its own behavior, allowing you to build complex functionality to the decorator. So let me show you guys an example. So here we have just a very simple decorator 1, decorator 2, right? You can see that oh, where's my pen? So we're defining a decorator here, my decorator number 1. So we're saying that here's my wrapper class, which we want to return. And we're saying that we want to print the decorator 1 before we call the function. And then and again, we're passing in the decorator, right? You're passing a function, right, into this decorator. And then our second decorator practically does the same thing. We created a second decorator, practically the same idea, right? We're gonna print decorator. We can do something before we call a function that we are passing through our decorators. So now because we're putting those decorators, 1, decorators 2, this will take it will call on the wrapper of the first decorator and then the wrapper of the second decorator, giving you the impression that we have decorator 1, decorator 2, and then it's going to print the original function. Let's see. Let me show you guys here the decorator. So you can see here, right? So it's going to call the decorator 1, decorator 2, and then the function, and then it's going to execute the function that we have here, which is my function. So we're going to have decorator 1, decorator 2, and then the function will be printed next. If I change this part right here to be the second, to be first, then you can actually change the order in which your execution would be will be implemented. So you can actually change the order of the function if you want to have the function be done first in the decorator. So practically what it does is that let's say that what it's going to do is that this function is going to take like this is going to be your function in here, like when you call the function here, it will be like decorator number 1 being called. And because in decorator number 1 you have decorator 1 being printed first, and then the function then is going to do that first, followed by the decorator 2. So imagine like you have this being called before the decorator, so you can see why you end up with this uh, formatted in this way. All right, so we can call as many decorators as we want, and we can create it, and then now we can call the function, right? So this is calling the function, and it's going to apply it. And then let's do the decorator with arguments. So Python decorators can also accept arguments, which allows more flexibility in their usage. When a decorator needs to accept arguments, you can define a decorator function that returns the actual decorator. So we can actually create a decorator factory, a function that returns a decorator function. This is pattern used when you need to pass arguments to the decorator. So let's say that that I need to have a decorator that takes arguments other than the function, right? So right now, as we can see, every decorator that we have done, it requires you pass in a function. You pass in a function, right? So every decorator that we have done, what you need to do is you need to pass in the function. But let's say that we want to pass other things to our decorator, something that is not a function. So what you can do is instead we can actually use another name of a function, which is going to be our decorator. So it's going to be like a nested decorator. And so what we're going to do here is we're going to define our decorator to be the repeat n. And what we're doing here is we're passing in another different argument, right? We can pass in whatever we want here, but in this case, we're passing the value n, which is probably an integer. And then inside this function, this decorator, we have this decorator. This decorator is going to take the function value. It's going to take the function value, and now we can define our wrapper. Inside this wrapper, what we're going to be doing is we're going to do a loop to go through every single element in our as n times. So that's where we're going to take the value n. As a result, right, we're passing in those values, right? We're passing those values into our function because it's going to give us a much more flexibility of whatever the function, the original function arguments are. Like, let's say we don't know what the original function arguments will be, but as long as we do that stars, it's going to give us the flexibility to take as many arguments as we want. So this is very flexible. So we can have as many arguments that we have for this that this function greet will need. So if you notice, this part is very similar to what we were been doing before. All we did is we added another layer to our decorator, where we actually pass in a an argument other than the function. But the inside part is what we were doing before. That's just our normal decorator. But what we have done is we added another layer to our decorator that takes another argument. So if we look at this, our decorator will be repeat, and what we're doing is we're passing in the value 3. And what we're doing here is gonna call this decorator, and this decorator, what is it gonna do is going to call that function 3 times. It's gonna do the function 3 times, and the function is in this case greet, right? That's the function that takes an argument, right? That name is what's being passed in here. Now, again, we don't know how many variables, how many arguments this function greet would need, but by having the stars there in front of it allows us to have that flexibility. And so what we're gonna do here is we're just gonna print hello Alice 3 times. So again, make sure that you type that into your replit. I'm gonna run this, and you can see Alice has been printed 3 times. Okay, so again, this was our normal what we've been doing before, right? You can see here, this is what we've been doing before, where we create a decorator and we have a return the wrapper, right? Within this decorator function that takes a function as an argument is going to have a function inside, which is going to be how we're gonna modify our function. But now what we have done is we added another layer. We added this layer right here, which is the how we can add another value to our decorator. Okay, all we did is just have this, and then what we do is we return the decorator function. We're just returning this function. It's just like the way we did for the wrapper, but now we're doing it for the decorator. So in the decorator, where we create this function and we return the wrapper. Now what we're doing we're doing in this case, right? We're creating this decorator that is creating this function, which is kind of like the wrapper, right? And we're returning that wrapper again. So if you want to think about it like that, right? Then just do it like this, right? It's like you have your decorator, this is your wrapper, and then this is what you're gonna return your wrapper, right? So it's kind of like that. But now what we do is we have a little more, we have another layer within this decorator, which is the wrapper, right? Now there is, we can build in our own decorators. Python provides several built-in decorators that serve, that serve as a common use for cases, for object-oriented programming. And you have probably seen some of this in a different type of language. But here, what we're doing is we're gonna go a little more detail on what this decorators do, and when you should use one versus the other. So we're gonna talk about the static method, the class method, the property method, and the differences between the class method and the static method. So the static method is just like the way you have probably seen in Java. It is a static method is a method that belongs to the class and not necessarily to the object, right? So this decorator uses to define static method within the class. Static methods do not have access to the instance or class itself and are primarily used as a utility function that are related to the class, but do not depend on the instance specified data. So you could actually create an instant variable and use the static method, but it does not depend on it. So a static method it's a method that is shared among the classes. So you don't need to define an object, an instance variable of that class to be able to use it. Just to remind you about that. So how it looks like? Well, you have your class. We're gonna call it my class 1. We're gonna define our method, a static method, And what we're doing here is we're defining our static method. We're gonna say this is my static method. It's very simple. Now, as you can see, we don't have to instantiate the object, but what we do is we call the name of the class. So the name of the class is my class one, and now we can call any static method. We can have as many static methods as we want. And so when you make a method static, and this is how we make it static in Python, is you just need to use the name of the class. My class one static method. So this is just how you create a static method in Python. Okay. And then let me clear this up. Let's look at the example. And let's remove this so we can see this static method. And you can see we're just returning the static method. Notice that I didn't have to create an object to essentially to call that method static method. I could do it if I want to. I could say my object equals my object equals my class one parenthesis, and then say my object dot static method. And you can see we are able to call the static method. So what I'm saying is that you don't need to instantiate the object. So this is, remember, this is how we instantiate an object in Python. And so this is my object right now, and I can use my object to call this method. But I don't need to do it because it's a static method. So remember in object-oriented programming, and when you create a static method, it means that you don't have to instantiate it with an object. You don't have to call it with an object. You can just call it with the class because the static method belongs to the class and not necessarily to the object. Okay. So that's a good way to remind you guys. I don't think that's something that you might have seen in 138, but this is something that I wanted to emphasize of how we can actually create a static method, which is a decorator. And then there's another decorator, which is called the class method. This decorator uses the define class method within the class. So the class method takes the class itself, CLS, at the first argument, allowing them to access and modify class label variables and methods. So let's say that you have a class number 2, right? Class 2, my class 2. And you have defined some variables and attributes for your class, and now you created a class method. Now this class method, in order, if you're gonna create a class method, you have to pass in the attribute CLS, which is gonna give you access to the class. And what we're saying here is that we're gonna be able to make some modifications to the attribute of the class. So remember, this is the class variable, and what we're saying is we're gonna make some modifications to the class variable by using the CLS. CLS represents the kind of like a saying like this, right? This class is kind of like that. It's like saying something like that. Self class number 1. So now what we can do is we can print the value of that variable. And now as you can see, we can use it as a static method, kind of like a static method. Without instantiating the object, we can still call the class method. So what the advantage of using this is that it gives you accessibility to any other variable and method within the class. Okay, so let's just go over that part in the code. So we look at that. We can see that we created this, that we're accessing, oops. We're creating this class method that was able to access the class variable. So you can see here, right, by calling the class method, right, it allows us to be able to, again, this is the class method. We are able to access a value that it was inside the class, something that we weren't able to do with the static method. Right, and so let's check the next part. And then the property is like a proper way of having to create our getters and setters. So it's just practically being able to a property will be able to property, it will be allows us to be able to it's kind of like a getter. And then for the setter will be value dot setter. So it's just practically our getters and setters, how you can actually access those values uh, without having to call the actual method. So here we're creating our class, right? So we have our class, class 3. We created this instantiation, right? Kind of like a constructor where we're defining that our self value is going to be equal to 0. This is going to allow us to be able to return the value of your attribute self value. Now, remember we put if we put underscore in the beginning, that means that it's private. So this is going to return the value which is private. And then this is going to set the value. So this is kind of like our setter. We're going to take a value, it's going to change, make sure that it's greater or equal to 0, and then save it. If it's not, it's going to return an error saying it's going to raise an exception saying that this is a non-negative value. You can see here we have to create in this case the object. We're going to be able to call, this is actually calling in on the setter and setting the value of the value. Notice that we didn't have to call the method. We actually do it, we're using the attribute in this case, even though it is private, right? We are actually kind of like using it as if it wasn't. And now this is actually doing the getter because we call them as property and as value setters as using the decorators. We don't actually have to call the methods that we have here, right? So let's see that in the code. So let's put that in here. So you can see we have the property 10. So we were able to print the value. Now, again, you could actually have done this in a different way. Object dot value. We can do 10, or let's do 15, and then do print object dot value. Okay, so the problem here, when we use this decorators property and value setter, what's happening is that we are turning those values, this method value into a getter, and we're turning this one into a setter. So automatically it's going to change them into those methods. And when you do that, then you cannot we cannot use them as if they were normal functions, or sorry, normal methods. And so we have to use them as, we can actually access them directly into their attributes. So it makes it, I know it's kind of like what it does is that Python kind of makes it a little bit, trying to make it easier by just being able to access the attribute directly, like in quotations. But in reality, what you're doing is you're calling on this method. You calling when you do this line right here, 159, what you're doing is that you're not actually accessing the attribute directly. What you're doing is you're practically accessing this method right here, which is a setter. So it kind of like makes it a little bit shorter, but it makes it a little more confusing. And what we're doing here is we're accessing the setter, sorry, the getter. But technically, we would have to, like, it would have been technically like this, right? Using what it's trying to do is trying to avoid uh, using all the notation for the setter and all. Sorry. Instead of using all this to be able to set the value, or what you're doing is just practically making it a little more practical, where you just it's kind of like going in directly and setting the value of that attribute, and then instead of calling the method value parentheses for the getter, it's just you can just call the name of the method. Now, let's say we don't want to do that, right? Let's say I want to actually do it the old way, right? How we actually do it in Java. Now, you can do it, but you would have to actually change the names of the methods, because in Python you're not allowed to have overload, right? You have to actually change the name of your methods, because you can actually modify the number of arguments that you have, so they're all going to be the same. So here, oh, this is one. And now you can see it's just going to be the same thing, right? So it makes it a little more practical the other way around. So I'm just going to change it back. So this is just having to make your getters and setters, right? And now let's see the differences between class method and static method. So a static method, let's just go with that one first, is let's say that you have a method and it doesn't need anything from the class. Like it's just a method and doesn't need no attribute, no other methods within the class. Then you can just make a static method. It's like having a utility method where you can just do a multiplication of what you're given, or the number or the attribute that you're given, and it just does that. So that's if the method is independent from any other information within the class. So for example, here we have this multiplication method, which is going to be static. So it's going to take the values that we're going to use, that is going to be passing, like x and y. It's going to multiply and it's going to return it. But let's say that in another case, right, you actually need information from, let's say you do, in order for that, kind of like you want to create this static method, but you do need information from the actual class. Let's say you need information from the initial, from, well, not that part, but yeah, so you actually need information from the actual value. So what it does is, so in this case, you need to pass in CLS, which is the name of the class. So it's referring to this class right here. And let's say you're passing 2 arguments for this class method. What it's doing is going to take in a value. So this is going to be like your constructor, right? Using the class, and it needs a value. One single value is going to take it in, and it's going to save it into the value. So this is actually accessing the self value from your class. So if you need to access information within the class, like an attribute or another method, then you should be using the class method. So that's the difference. If you don't need anything from the class, use the static method. If you need information like methods and other attributes, then you use the class method. They're very similar in the sense that they don't need an object to be able to be called on. You just need the class. But the difference is that if you don't need anything from the class itself, then you can just make it as a static method. But if you do need information from the class itself, then you want to do is you want to use a class method. Okay. So here you can see we're adding here we're calling the class name. We're using the static method. And I probably should, oh sorry, this is the class, sorry, this is using the class method. because we're actually using this method right here. This is a class method where we're passing in two informations, 3 and 5. It's going to add it and it's going to return it. So the actual result added will be the result of the add value, right? So we're going to be able to access the value of your class. So that's what, remember we said that this is going to representing the value. So this is going to save the information into your value. So that's what we're doing here. So that's practically what this is. It's just gonna save the value. It's gonna add them together and save it as a value. Here, this is just gonna multiply them together. So you can see here, doesn't need to call the class, the value of the class is just gonna return the value. All right. Wait, sorry. Right, so let's see that in the code. So we comment that. Make sure you guys copy this. And then put it to the top. So again, what we're doing is we're creating this static versus class methods, right? And again, we're just creating this class called math. Is going to have initiator. This is our class method. Here's our static method. Again, a class method is like in the constructor to save the value x plus y, whatever we get from x plus y, we're gonna save it into our self value. And so then, so it's going, if we ever want to get the actual sum, we need to get it from the self value. And then for the method, for the static method, that's if you don't need anything. So again, that's the same thing that we just talked about. Okay. All right, so hopefully that gives you an idea of the decorators, just different varieties that we can use within the class and within the functions. All right, so make sure that you guys copy this, put it into the code, into your replit, and then submit it into Canvas. Sorry, yes, Canvas as a section for the video. Okay. All right, I'll see you guys next time. Bye.